Now in this lesson we're going to look at the process of integration. Now integration is simply the exact opposite of differentiation. We'll look at a few rules. The integral of x to the n dx is equal to x to the n plus 1 over n plus 1 plus c, where we say c is our constant of integration. So let's look at a simple example here illustrating this. Integral of x squared dx. The integral of x squared dx, well, with our squared we're going to add 1. So x squared will become x to the power of 3, and we write x to the power of 3 over the 3 plus c on the end. Right, so that would be known as an indefinite integral. That's why we use the constant at the end. A definite integral involves what's known as limits. So same example, but we have this 2 and 1 as our limits. So the integral of x squared, okay, as before, x to the power of 3 over 3. And then because we have these limits of 1 and 2, we use the brackets. We put the 2 and the 1. And then what we do now is to substitute. Firstly, we're going to substitute the 2 where we see x. So we'll have 2 cubed over 3. Then we subtract. And then we're going to substitute 1. So we put that in. We get 1 cubed over 3. Very good. At this stage then we just simplify that small small subtraction there. End up getting 7/3. Very good. Now the next rule of integration is that the integral of k dx, where k is just a constant, will equal kx. And we write plus c on the end, our constant of integration. So, for example, if we're asked to integrate 6 dx, now the dx simply means with respect to x. That's why we're integrating in terms of x. So, integral of 6 dx will simply be the 6 we just integrate becomes 6x. That's all. So if you have just a number, we just integrate it and include the letter with it, 6x, plus c on the end. Then the next rule we'll consider the integral of ax plus b all to the power of n dx. Right, we'll write that as ax plus b to the power of n plus 1, so we add 1 to the indice and put it over n plus 1. There's one little extra step. We look at the coefficient of x. In this case would be a, and we multiply the bottom there by a. Again we write plus c on the end. Tremendous. We'll look at a few examples now. Firstly, the integral of 2x plus 10 dx. Well, we'll just integrate one term at a time there. The integral of 2x, well, we write the 2 down, and the x, if you like, is x to the power of 1. So we add 1 and become x to the power of 2 over 2. So we have 2x squared over 2 there. Now the integral of positive 10 would be positive 10x. We must write the constant at the end. And then we can simplify that to being x squared plus 10x plus c, where all we've done there, those 2's there we can see would have cancelled out. Question 2. Integral of x to the 5 plus 1 over x to the 4 dx. Well, we'll need to rewrite that because we can't have any fractions with x on the bottom, so we've just changed the 1 on x to the 4, we've rewritten it as x to the power of negative 4. So let's integrate one thing at a time. X to the 5 will be x to the 6 over 6. Okay, don't forget we're adding 1. Now x to the minus 4, now this is where, a few people strike a few problems here. If we add 1 to minus 4, we get x to the minus 3. Alright, were you thinking minus 5? Okay, I hope not. X to the minus 3 over minus 3, and we add c. And finally we can write it as that, where we have a plus and then a negative. Okay, we're adding a negative term, we just leave it as a negative in the middle there. Okay, question 3. 2x plus 9, this time everything is to the power of 7. Well, with this sort of result, we write 2x plus 9 to the power of 8. Okay, we've gone up 1, and we put it over 8. Now there's one little extra step here. We look at the coefficient of x, which is 2. So on the bottom there we're going to multiply by 2. We write the plus c at the end, And we can just simplify that then to being 2x plus 9 all to the power of 8 over 16, since 8 2's are 16, and then we write plus c. Now question 4 this time involves limits. The limits are 4 and 1. Well, the first step is to rewrite that because we don't want any square roots. So we've had the replace the square root of x with x to the power of a half. Now let's integrate. The integral of 2 is just a number, so the integral is 2x. Now x to the half, well, we need to add 1 to the half, and that would make it 1.5. Now 1.5 can be written as 3 halves, so we write plus x to the power of 3 halves over 3 halves. And because this time we're dealing with limits, we're going to use the big box brackets and we'll write 4 and 1. Now we can rewrite that as such, and all we've done in that step is, see how we're dividing by 3 halves? Well, if you divide by a fraction, you multiply by the reciprocal. So we multiply by 2/3. So again, if we divide by 3 over 2, we multiply by 2 over 3. Very good. Now at this stage now, we need to substitute our limits. Firstly, the 4. If we replace x with the number 4 wherever we see it, we come up with that. Then we subtract. Okay, it's minus. And then we're going to do the same substitution, but this time with the number 1. So wherever we see x in that little expression there, we put 1. And make sure it's in brackets because we're subtracting that whole lot. Then we'll work out the brackets individually. Firstly, if we work out that bracket, you'll come up with 13 and 1/3. And then we're subtracting this bracket, so if we work out that bracket separately, we eventually find that we need to subtract 2 and 2/3. Tremendous. At this stage then, fairly simple. 13 and 1/3 minus 2 and 2/3 works out to be 10 and 2/3.